Well, good evening. Just give me a moment. We're using a new pad. Okay, yeah. So, one of the important rules that we have in thermal physics is gas laws. And how many hours we teach this in the class, still I observe many of the students make a mistake. So, I took up one of these problems. Okay, of course, errors happens in every gas law, but this is one problem I just took it across. So, you can use it in any of these gas laws. Okay, so gas law states that something like pressure is directly proportional to temperature at constant volume. Okay, you have three different laws. I hope you are all aware of this. Okay, one is it says P is inversely proportional to volume at T equal to constant. And the second one it says is that V is directly proportional to T at P equal to constant, pressure equal to constant. And the last one it tells you is about we have related PV, then we have related VT, then we have to relate PT. P is proportional to temperature at constantly, at V equal to constant. So these are the three important laws that we have. First one is known as the Boyle's law, second one is Stahl's law, and third one is Gay-Lussac's law. Combining all these three laws, we have this PV by T equal to a constant, which is nothing but your ideal gas law. This is applicable only for a ideal gas. Okay, so this is what we have learned so far with respect to the gas laws. And one thing that you need to note here is that the units. The temperature here is always measured in terms of Kelvin. Okay, whether here or here or here, wherever it is, temperature is measured in Kelvin. Okay, so towards it. Now let us read this question. The temperature of fixed mass of an ideal gas goes from 40 to 80. It means your initial temperature is T1 and the final temperature you are doubling at constant volume. The moment we say constant volume, there are three laws here. We first need to identify which law we are talking about. So the first law you cannot apply because you see here temperature equal to constant, but here volume is constant. So you cannot use this law also. So you can use only this law here, where pressure is proportional to temperature. Okay. So by reading this, so we know that we are going to use your Gay-Lussac's law. We are going to use your Gay-Lussac's law. Gay-Lussac's law. Okay. Wherein it says that P is proportional to T at constant volume, which means when temperature increases, pressure also increases. Okay. Now here you see ideal gas goes from 40 to 80 degrees centigrade. That means temperature is doubled. The moment we hear that temperature is doubled, so immediately we also think that okay, pressure should also get doubled, right? So because pressure is proportional to temperature, and students immediately mark this as a right answer because you see the initial pressure was 121, and then doubled of this one should be 242. Now, do you think this is correct? It's totally incorrect. Okay. So around 50 to 60% of the students make this mistake. Okay. They're thinking that, okay, they come and argue with me later on also saying that, see, I have applied the law correctly. But though you applied the law correctly, but still your answer matters. You're not applied it correctly. You're not substituted the value, so you will not get it correctly. So this is incorrect. Some of them, they put it across something like P is half of it. So they get this answer and so on. Now let us see what's happening over here. Now when I say temperature is T1, you should now convert this temperature T1 to Kelvin. Now how do I convert? You should add 273 here. 273 plus 40 will be equal to how much? 3, 4 plus 7 is 11, 313 Kelvin. It's your temperature. And the temperature T2. What is temperature T2? This should be 330, 273 plus 80. 273 plus 80, which should be, once again, 3, 8 plus 7 is 15, 1, 353, 353 Kelvin. Now what you need to do is you can apply this rule. Okay, what is that you need? You need P2 because P1 is already given to you. What is P1? P1 is given as 121 kilopascals. So you need to find out the value of P2. So what do I do? Apply the rule. P2 by P1 is equal to T2 by T1. In other words, P2 is equal to P1 into T2 by T1, which should be, what is P1? 121 kilopascals multiplied by T2. What is T2? 353 divided by T1. What is T1? T1 is 330. Is the difference over here? Okay, let us use a calculator to get to know what is the correct answer. Just give me a moment. I'm just calculating this. So I have 353 353 divided by 313 is equal to 1.12. Then multiply this by 1.12. 121, sorry. 121, which will give me 136 Kelvin. 136. What is this 136? 136 kilopascal. Oh my God, there's no answer over here. Okay, so one of these answers, I'll just strike out this one here, and I will say this is 136 kilopascals, right? So therefore, D should have been the right answer. Okay, so therefore, all these answers are incorrect. I hope you understood this problem. Okay, how to solve problems in gas laws, especially when you have problems in thermal physics. Do first convert it to Kelvin. Okay, so this is the misconception. Most of the students do it because we are all used to something like degree Celsius. Okay, so never have any temperature in calculation at degree Celsius. Convert it to Kelvin. Okay, this is a shortcut. Thank you, friends, for watching this video. And if you like it more, do share and subscribe this to my channel so that it gives me a lot of appreciation and views and even helps me in improving one video. So do comment on it also. Thank you.